Hello everybody, welcome to Computer Vision 2, which is all about applications. I'm so excited to invite you to this very practical and hands-on course. Good courses are all about the right emphasis. The emphasis for this course is teaching the tools and techniques that will help you build computer vision and machine learning applications. We will use many different frameworks and libraries in addition to OpenCV. This is because when you're solving an engineering problem, you cannot be married to one tool. You use the tool that is right for the job, and you need to be able to use a wide variety of tools. Before I jump into an overview, let's look at the prerequisites for this course. First, you need to have an intermediate level of knowledge of Python or C++. Second, you need to be familiar with the OpenCV library. Third, you need to have some understanding of computer vision techniques. And finally, knowing a bit of machine learning techniques like support vector machine will help a lot. If you have taken Computer Vision 1, you are very well prepared for this course. Now let's go over the goals for this course. First, I want to emphasize that this course is engineering oriented and focused on applications. Going very deep into theory is not the emphasis of this course. Second, we will learn a lot of tools necessary to get the job done. These are tools you will not learn in a university course. For example, when explaining object detection, we will go over the tools you can use for data annotation. And finally, our focus is on building applications. Every technique we teach will help you build some application or the other. Now, let's go over the topics we will cover in the course. We will start with face-based applications. There are a few reasons why these face-based applications are very important. First, a vast majority of photos and videos contain faces. Processing and analyzing faces is an area rich with applications, jobs, and opportunities. Trust me, Snapchat filters are just a start. Second, even before the word selfie was invented, a vast majority of computer vision and machine learning algorithms were developed for and applied to human faces. So let's dive into the details. We will start with facial landmark detection. You will start appreciating the importance of facial landmark detection by the fact that a version of facial landmark detection ships with iOS. Yes, it is built into the operating system. That's how important it is. We will learn one such technique in detail. You will become an expert in training a landmark detector from scratch. This includes understanding the theory, the parameters, the tools of data annotation, and the practical tips to train a good model. We will also learn how to stabilize the landmark points in a video. While covering the background for facial landmark detection, we will cover the basics of machine learning algorithms like bagging, boosting, decision trees, and gradient boosting. Armed with a solid understanding of facial landmark detection, we will build many applications on top of it. We will start with face averaging. Building on the same ideas, we will cover face morphing. But why just stick to humans? We will have some fun morphing Hillary Clinton into a tiger. But the fun doesn't stop there. We will build a face swapping application and create some disturbing images. Next, we will build a few Snapchat filters. Technique-wise, we will cover some complex nonlinear warping techniques, Delaunay triangulation, and image blending. Next, we will move on to blink and drowsiness detection. Lastly, we will cover face recognition. First, we will learn a bit of history of face recognition with eigenfaces and Fisher faces before covering a modern deep learning based approach. Well, that's all about faces. Next, we will move on to algorithms for video analysis like background subtraction. Another important category in computer vision is text detection and optical character recognition. These techniques are very useful in applications like document analysis and automatic number plate recognition. Next, we will cover image classification. We explain how to train an image classifier and use it in different applications. Now, this is not a course on deep learning, so we will not go deep into the theory, but focus on practical issues like which architecture to choose for what kind of applications. Next, we will cover object detection. We will learn one state-of-the-art object detector in depth and learn how to train it from scratch. We will also learn how to debug the training process and improve the model. Finally, we will go over the annotation tools that you can use for data annotation. Next comes an important question. Say you have built an application, but how do you make it available for use? There are many different ways. You could build a desktop application, a mobile application, or a web API. It is impossible for us to cover all the different platforms, so we chose a common one that is widely applicable. In my consulting business, 80% of the time, the machine learning solution is developed as a web application. Usually, an image is sent using a REST API to a web server where it is processed and some solution is returned. For example, you may have a face verification service. You may want to detect the face on the edge device or the camera, but send it to a central server for face verification. This central server should be able to handle requests from multiple cameras simultaneously. To accomplish this task, we will learn about tools like Flask and platforms like Amazon Web Services. That should give you a good overview of what we are going to cover. Yet again, welcome to the course. It is going to be an exciting journey. Thank you.